Lesson 2.1, we're starting chapter 2 today, is properties of equality. Basically, what you're doing is we will be solving equations and also learning how to check your answer um, to make sure that it's correct. So we're going to go over some vocabulary first. The first one is a mathematical sentence stating that two quantities or expressions are equal to each other, and that is an equation. Okay. And some of your quizzes do have vocab on them, so it'd be good to review these. The next one, find the value of a variable in an equation that makes the equation true. Basically, that is your answer or your solution to the equation. So when you get down to the bottom and you have x equals something, that something is your solution. Getting variables alone on one side of the equation is called isolate. And you hear me say that a lot when we're solving equations. The same term is added to or subtracted from both sides of the equation, and that is the addition property of equality. Not subtraction. Even though you can subtract. And then the next one, if each side of an equation is multiplied by or divided by the same number, that is the multiplication property of equality, not division. Okay, so those are your vocab words. Um, I know you guys did this last year. We're going to start off by checking to see if a solution will make your equation true. And you can use this at any time. A lot of students don't like to check. That's fine as well. But what you can do is if you get to an answer where you get x equals 11. You could plug that 11 back into the equation where x is and solve. So let's go ahead and do that. We're going to plug 11 into x. And when we plug, what I'm saying is we're substituting x. We're getting rid of the x and replacing it with the solution. Okay, and when you solve this, you get 9 equals 10. 9 does not equal 10. So 11 is not a solution, and you can abbreviate solution. Okay. So this is okay. All right. I'm going to do example 3 and then you'll do examples 2 and 4. The same thing with the 8. If you get to the bottom, x equals 8, and you want to check it, you're going to substitute the 8 into where the x is. Now, 2 is being multiplied by x. So when you set this up, it's going to be 2 times 8 plus 7 equals 15. Okay. And then you just solve it. So 2 times 8 is 16. 16 plus 7 is 23. 23 does not equal 15. So 8 is not a solution. And that would be your final answer. Okay. All right, I want you guys to go ahead and do example 2 and 4. And on your homework, you must show your work just like this, okay? So I'm going to do it up here. You just check your answer. Okay. Any questions on these? All right. Easy enough. Let's go ahead and move on to page 2. Now we're just solving equations, one-step equations involving addition and subtraction. So if you look up at our examples here, x minus 3 equals 6, we're going to use the addition property of equality, and we're going to do the opposite of minus 3, and we're going to add 3 to both sides. So that's what they did here. They added 3 to both sides. Negative 3 plus 3 is 0, so you just cancel that out. And 6 plus 3 is 9, so x equals 9. Now, when you come over here to solving with subtraction, it's still the addition property of equality, but this time you're going to do the opposite of adding 3, and you're going to subtract 3 from both sides. So you cancel it out on this side. 6 minus 3 equals 3. You will not always see the equation set up just like this, okay? Sometimes x will be on the other side, all right? So let's go ahead and start solving these. And I do want you to show each step, even though in your head you know x equals 8, we're still going to show that one step. So we're going to subtract 2 on both sides. And we get rid of that because 2 minus 2 is 0. And we're left with x equals 8. Okay. All right. We're going to do the left side, and then you can do the right side. Okay. Now we're dealing with fractions. Yippee skippy. Okay. So I did teach you how to clear your fractions. So you can clear your fractions, or you can work with fractions, whatever you'd like to do. So I'm going to clear my fraction over here. I'm going to work with my fraction over here. So I'm going to rewrite my problem. When you clear your fraction, you have to find a common denominator. And did I teach you how to clear fractions? Oh, you know what? That was my other class. Okay, let's just deal with fractions on here. So we're going to add 3/5 to both sides. Okay. Negative 3/5 plus 3/5 cancels out. All right. So now we have to add 1/3 and 3/5. So when you do this, you have to find a common denominator, which is 15. To make the 3 of 15, I have to multiply by 5. If I multiply the 3 by 5, I have to multiply the 1 by 5. To make the 5 on the other fraction of 15, I have to multiply by 3. If I multiply the denominator by 3, I have to multiply my numerator by 3. So what I end up with is y equals 5/3, and I'm going to write it this, oh, not 5/3, not 5/3, sorry, 5/15. What? Yeah, I'm going to add it. Plus 9/15, and y equals 14/15. Okay. Since it's been a while since you've done fractions, are there any questions on how to solve those? Okay. When you get to the 8 over here and you have to subtract 3/4, you could put your 8 over 1 and then just change this denominator to 4, okay? When you get there. All right. Example 9. Since we're adding 0.4, we're going to use the addition property of equality and subtract 0.4 on both sides. Now, what happens when you have when you're adding two negatives? You're adding, and then it takes on the sign of the negative because they're both negative. So you end up with negative 0.9. Be very careful with those, though. All right. This next one, notice the x is not first, but the process still is the same. 12 is negative. So we have to do the inverse of that, and we have to add 12 to both sides. Okay. We always look at the sign in front of the number, and we do the opposite of that. Okay. What I want you to do now is I want you to solve the evens, and then we will come back and check them together. Also, check them with your partner and see if you came up with the same answer. So I'm going to pause the video right now. Okay, so I want you to go ahead and check these. They're um, please leave your fractions improper. So if you put 7 and 1/4, it's the same as 29 over 4. But if you could get in the habit of leaving just regular number problems as fractions, please do that. Um, Number 10, I just want to go over for a second because I did notice some students on one of the homeworks set this up incorrectly. So you have 9 plus 2.4. That is like 9.0 plus 2.4. You have to line up your decimals to get the correct answer. I've seen like 92.4 or 3.3, I think. So this is 11.4. Okay, now the last one. When you add 9 to both sides, you still have a negative x. We cannot have a negative x. You must get rid of the negative. Now, the negative x is like a -1. So there's two things you could do. You can multiply both sides by -1, or you can divide both sides by -1. I usually divide. Okay. Once you do this, the negative ones cancel out. They basically, two negatives become a positive, and you're left with x equals 4 divided by -1, which is a -4. So be very careful with those when you see that a variable has a negative. A lot of times students forget to carry the negative with the x if there is one in front of it. So, all right, any questions? Okay, let's go to page 3. All right. So now we're moving over to the multiplication property of equality, where you are either multiplying or dividing both sides by the same number. So your goal here is to isolate the variable by completing the opposite operation. 3 is being multiplied by x. So we are going to divide by x. A lot of times students want to subtract. Don't do that. You're going to divide both sides by 3, and you will get x equals 4. And these examples up here are pretty clear too. Okay. All right, the next one, I'm doing example 15. This is the same as 1/5 x equals 3, okay? Anytime you have a fraction, you want to multiply by the reciprocal. So it's the same as saying, okay, 1/5 x, I'm going to divide both sides by a fifth, but that's a lot more work. So you can multiply by the reciprocal of 1/5, and that would look like this. 5 over 1, and then times 5 over 1. Now, you really don't need the over 1, okay? But sometimes that's just how people write it. But what is 5 over 1 times 1/5? They cancel out. If you look at it over here, 5 over 1 times 1 over 5, you multiply straight across and you get 5 over 5, which equals 1. So this really becomes 1x, but we don't need the 1 in front of the x. So these can cancel out, and we're left with x equals 3 times 5, which is 15. Now, if you wanted to check it, you don't have to. You could plug the 15 into where the x is, substitute it, and 15 over 5 does equal 3. Okay, so 3 equals 3, and it checks out. Any questions about that? All right. Example 17 is the same thing. 3/4 x equals 6. We're going to multiply by the reciprocal. So I'm going to multiply this side by 4/3, and I'm going to multiply this side by 4/3. And if it helps, you can put your 6 over a 1. Okay? These cancel out or become a 1. And when you multiply with fractions, you just multiply the two numerators together and the two denominators. So I end up with 24 over 3. Make sure, though, that if you can reduce the fraction, that you do so. So 24 divided by 3 is 8. Okay? You can use your calculator on this lesson also. Did I do something wrong? No. Okay. Notice that all of these are different. It's because you're going to see all of these types in your notes. Okay. Yes. Mhm. All right, 19, I'm going to multiply by the reciprocal of negative 2/3. But when I multiply by the reciprocal of a negative, I have to multiply by the negative reciprocal. So on this one, we're going to multiply by negative 3/2. So if it's negative, multiply by a negative. If it's a positive, multiply by a positive. So I'm going to multiply this one by a negative 3/2. And I'm going to put my 12 over 1. Okay, these cancel out and become a positive 1x or just x. And then when I solve this over here, and I should have done that up here too, 24/3, I get a negative 36 over 2. What's 36 divided? Negative 18. So my answer here would be negative 18. Okay. One more before you do the right column on your own. We're going to multiply by the reciprocal again. Okay. And since it's negative, we're going to multiply by the negative reciprocal of negative 7/5 on both sides. Okay, this cancels out over here. Now, some of you may not be used to cross simplifying or cross reducing fractions. So this might be a little bit challenging, but let me just show you the cross simplifying and then I'll show you the other way. Okay, so 12 and 5 cannot be reduced. So the two numbers across from each other cannot be reduced here, but the 7 and the 49 can. So I can reduce these both by 7. It would be like taking negative 7 over 49 and simplifying it. Okay, you would divide them both by a negative 7 or 7, not a negative. And so when you do that, this becomes a negative 1 and this becomes a positive 7. So 12 over 7. So then I'm multiplying straight across and I end up with 12 times the negative 1 is negative 12 and 7 times 5 is 35. Okay. Now, for those of you who are not used to cross simplifying, I'm going to show you what it would be like to multiply 12 over 49 times negative 7 over 5. I'm going to do that over here. So I'm going to use my calculator. Oh, I don't know. Oh, here it is. You're going to get some very large numbers. And so that's why it's good to learn how to cross simplify. So 12 times negative 7 is negative 84. And 49 times 5 is 245. Once you get to this spot, you're going to have to simplify it somehow. Okay. So you're going to have to figure out a common factor and reduce it all the way down to negative 12 over 35. Okay. And you would have to reduce them both by 7. Any questions? All right, I would like for you to go ahead and do the right column, and then we will come back and check them. So I'm going to pause the video, and when we come back, you will see the answer. Oop. Okay, go ahead and check your answers. Oop. And then here's 22. Yes.
Can you tell us how you did example 16? Like the steps of it?
Yes. Okay. So on example 16, this is like 1 over 0.3x equals 4. So I have to do, it's like multiplying by the reciprocal. So I'm going to multiply by 0.3 over 1. Now on this one, I just multiplied by 0.3, but it's the same, really. And so these cancel out. And then if I multiply this by 0.3, I have to multiply this by 0.3. And so I end up with x equals, and then 4 times 0.3 is 1.2. Are there any other questions on this? Okay, let's go ahead and go to the back. We have solved, or we have written out word problems in chapter 1. We did that, but now we are going to solve them. Okay. So there are some steps up here, but I'm going to show you the steps down here. But if you ever needed to refer to this, you could. All right, notice that the directions say that we're going to write an equation and be solved. There are 2 parts to this, so make sure you're doing both parts. So the first thing that I'm going to do is I'm going to write out my equation. So it says that the sum of a number and 32 is 11. So that one we wrote it out. However, the sum needs to be moved over to the word and. I don't know if you remember doing that in the other lessons, but we're taking the sum of the number and 32. So we're adding those 2 together. So when we write out our equation, we end up with n plus 32 equals 11. This is A. So this right here is our first answer. You must write out the equation. That's part of this lesson, is learning how to write out the equations. So I don't want to see 32 minus 11 and then your answer. I actually want to see a variable in the equation. Okay. Then it asks, what is that number? So what is this number right here? So I'm going to rewrite my equation over here. And yes, you do need to show your steps to solving it. And we're going to subtract 32 on both sides. Okay. And we get n equals negative 21. So over here, B is negative 21. So that's the second part to our problem. So on a question like this in your book, it would be 3 points, 2 points for the equation and 1 point for the answer. Okay. Okay. I would like for you to try to write out the equation for 24 on your own, and then we'll check that before you solve it. Okay. So go ahead and try that one. And I'm just going to annotate while I'm waiting for you guys. So. Okay, I annotated, but that doesn't mean that that is the correct equation. So, does anyone want to tell me how should we write out the equation? Go ahead, Julian.
One is equal to 14 minus 6.
Yeah, 14 minus 6 because it's 6 less than the 14. So you have to switch the 6 and the 14. Okay? Now, I'm going to rewrite it over here. The first thing that we need to do is we need to add that 14 or subtract the 14 and 6. Okay? So we have 1/2 n equals 8. Then you solve it like we just did on the previous side, and you are going to multiply by the reciprocal. Now, when I multiply by the reciprocal, when my numerator is 1, really all I'm doing is just multiplying both sides by that denominator. Okay? And then this cancels out, and I'm left with n equals 16. Okay. Okay. Any questions about that? Okay. I would like for you to do 25 on your own. And then we're going to do 26 and 27 together. So I'm going to pause the video and let you do that one, and then we'll come back. Okay, so because this word problem is asking for something specific, you need to make sure that you don't just put m equals 27, but you say what that 27 represents, and that represents how old Samantha is. You could put Samantha's age is 27 or whatever. Okay. Okay, this next one is a little bit tricky. In 11 years, Joshua will be 19 years old. Well, maybe it's not. Megan? Yeah. So, and I put J just because it's Joshua. Oh, that wasn't as tricky as I thought. Okay, so in 11 years, so if you add 11 to Joshua's age, he will be 19. Yes. You could. Mhm. Yeah, and so then this one would be, whoops, I did that wrong. And then solve it. And so I'm going to put Joshua will be, oh, Joshua is 8 years old. Yeah. All right. Good. Now read example 27. See if you could come up with the equation. This is our last one. And then check with a partner, see if you got the correct equation, and then solve it.
So I mean, if you could check it so that
So this should be your answer. Make sure you write out that the bike was 5225, not just 5225. What was 5225? Some of you may have put 5750 minus 525 equals X. That might have been a different equation that you used. This is just this is the most proper way, but yes, you can. Okay. All right, that concludes lesson 2.1, properties of equality.